You know, we all think we know how to ride a bike. It's that classic thing, right? You learn it once, you never forget. But what if I told you that the simple act of staying upright is so ridiculously complex it had artificial intelligence totally stumped for years? Well, today we're going to dig into this incredible paper that found an almost impossibly simple secret to teaching a computer to do it. But first, I have a quick question for you, just to get your brain working. Picture this. You're cruising along. You want to make a right turn. Which way do you first push the handlebars? To the right or to the left? Go on, think about it. Most of us just do it, without a second thought. The answer, and this messes with a lot of people's heads, is to the left. Yeah, to lean the bike right so you can start a right turn, you first have to push the point where the tire touches the ground out to the left. That tiny split-second countersteer is the first clue, and it points to something huge. Our bodies know things that our conscious minds have no idea how to explain. And that right there, that's the paradox. If we can't even put the rules into words, how in the world are we supposed to teach a computer to do it? This is where our investigation gets really interesting. So, a team of researchers decided to tackle this. They set out to build a virtual bicycle controller, and their first idea was, a classic AI approach. Just let the machine figure it out on its own. The technique they used is called reinforcement learning. And the idea behind it is pretty straightforward. You give the AI a goal, a reward, and then you just let it try millions and millions of random things, learning from what works and what doesn't. It's basically trial and error, but on a massive computational scale. The hope was the AI would just stumble upon the secret to riding a bike all by itself.
But here's where they hit a wall. What is the goal of riding a bike? Sounds simple, but for a computer, it's a nightmare to define. Is the main goal just to stay upright? Or is it maybe to go in a straight line? They decided to try both.
And the results were kind of hilarious. When they told the AI its only job was to stay upright, it found this bizarre loophole. It learned it could balance perfectly at almost a dead stop just by spinning the handlebars around in circles. I mean, technically it was achieving the goal, but it wasn't riding a bike. It was doing some weird circus act. So they tried the opposite, and that failed just as spectacularly. When the AI's only reward was for going in a perfectly straight line, it did that for about a half a second before it just, fell right over. It couldn't make any of those little adjustments you need to stay balanced. So yeah, the whole brute force method was a total bust. The AI was either a stunt rider or it was a complete disaster. The researchers realized they had to change tactics. It was time to stop guessing and go talk to the real experts. And this is where the whole story pivots. Instead of throwing more computer power at the problem, the team turned to human intuition. They went looking for a clue that the AI had completely missed. They had two ways of doing this. First, the high-tech way. They recorded every single tiny movement a person made while riding a virtual bike, every little twitch of the handlebars, every shift in balance, and fed all that data into a computer, hoping to find a pattern. And second, the super low-tech way. They just asked the riders, hey, what are you thinking about when you do this? Okay, so the data crunching approach, it was a complete dead end. The information was just too noisy, too chaotic. Any secret pattern of what an expert rider does was just buried so deep in all that information that the computers couldn't find a thing. It was just a mess. But just talking to people, that's where they struck gold. That was the aha moment. All the human riders said pretty much the same thing. They weren't thinking about their speed or the exact direction or the handlebar position. They were focused on one thing and one thing only, the lean of the bike. The secret wasn't steering to go somewhere. It was steering to control the fall. And that one single insight changed absolutely everything. Armed with this new piece of knowledge, the researchers tossed out all the complicated AI stuff, and they built something totally new. Something focused, elegant, and almost shockingly simple. They built a controller using just 2 artificial neurons. 2. Neuron 1 had exactly one job: figure out what the target lean angle should be, and Neuron 2's only job was to move the handlebars to make the bike hit that angle. That's it. It's so clean, so simple. I mean, look at how simple this is. You've got the lean brain that decides, okay, to turn right, I need to lean right at about 5 degrees. Then you've got the steering muscle that does whatever it has to do with the handlebars, including that little countersteer we talked about, to make the bike hit that 5-degree lean. One neuron thinks, the other one acts. So we've got our 2 contenders. On one side, the chaotic, brute force AI that tries a million things. On the other, the super elegant 2-neuron network built from a single piece of human wisdom. Let's see how they stacked up. I mean, this is the big question, right? After all those complex AIs just crashed and burned, could this ridiculously simple system actually work? Could two little neurons really ride a bicycle? Oh, it worked. It worked perfectly. The control wasn't just stable, it was incredibly precise. So precise, in fact, that it could follow a complex path of waypoints to flawlessly trace out the author's name on the virtual ground. I mean, no human could do that, and the complex AI couldn't even dream of it. And this comparison, this is the whole story right here. The brute force AI, after thousands of tries, still rode like it was drunk. The two-neuron network? It worked almost instantly with perfect precision. It's the ultimate proof that a tiny bit of the right insight is worth more than a mountain of raw computing power. But the story doesn't just end there. The author himself points toward the next great challenge, which is basically taking the human out of the loop. He says the ultimate goal is for the computer to figure out these simple, elegant solutions all by itself, without a person needing to give it that ha-ha moment. And that's really the thought I want to leave you with. This time, it took a human to step in and say, hey, forget everything else, just focus on the lean. But can we design an AI that has its own flashes of insight? An AI that doesn't just crunch the data, but actually finds that simple, elegant truth that's hiding inside a complex problem? That right there, that might just be the next great frontier.